tomorrow will be better. In this other set of exponential equations, I'm going to be teaching you how to attempt problems in which both sides of the equality signs don't have the same base. Alright, so follow me, let me show you what to do. Solution. Let me copy this again. We have 7 to the power of x minus 7 raised to the power of x plus 1. This gives us negative 42 on the other side. Now, there's some little simplification we have to do before we start applying the rules of indices here. Notably, look at the left side of the equation. It has two terms, each of which has an x and an x. So, now, look at the second term on the left side of the equation. I can also rewrite it as, let me say back, 7x plus 1 is also the same as 7 to the power x times 7 to the power of 1. Now this symbolizes times and not plus or decimal. Why did we use this? From one of the laws of indices, which states that a to the power of n times a to the power this time around of n is the same as a to the power of n times n. So I've just reversed this identity, okay? So it holds whichever sense you put it. So I'm just going to replace this second term by this expanded form. So I'm going to have that 7 to the power of x minus 7 to the power of x times 7 to the power of 1. This gives me negative 42. Now look at something here. There's a 7 to the power of x here and there's another one here. So the first thing that should come to mind here is to factorize, okay? I'm going to factor out one of this to look like this. 7 to the power of x. When I factor it out here, I'm left with just 1. And then when I factor it out here, I'm left with only 7 to the power of 1. Very good. 7 to the power of 1 is equal to negative 42. If you haven't subscribed to my YouTube channel yet, this is the time to do so. Okay, at this point, we kind of have a term here and some sort of a coefficient here, okay? And given that this is our term of interest here, what we were going to do here is we're going to divide both sides by this coefficient here in order to isolate this term. Okay, let's do that real quickly. So I'm going to have that 7 to the power of x into 1 minus 7 to the power of 1 is equal to negative 42, and I'm dividing the two sides by 1 minus 7 to the power of 1 all over 1 minus 7 to the power of 1. Dear friends, up to this level, I hope each of you has noticed that 1 minus 7 to the power of 1 can be further simplified, and this is nothing else but negative 6, okay, because 7 to the power of 1 is just 7. And 1 minus 7 is just negative 6. Okay, be very careful. So this means we have 7 to the power of x is equal to negative 42 all over negative 6. These two fall off and this gives me plus 7. Now be very careful. Now we have the same basis on both sides. Alright, because 7 is still the same as 7 to the power of 1. So finally, we're having 7 to the x is equal to 7 to the power of 1. Now that the bases are the same, we can equate their indices. Therefore, x is nothing else but 1 for the first question. Now let us look at the second question here, which says 8 to the power of 5x is equal to 4 to the power of 4x minus 7. At first sight, we will say, oh no, these two are not the same. We cannot express 8 in terms of 4 with an index, okay? So what do we do? But notice that there's a common other base which both sides can have, alright? Notably, you will say, but 4, which is on the right side, is the same as 2 to the power 2, and 8 on the left side is the same as 2 to the power of 3, okay? So I'm going to express the two sides with this expanded form. So I'm going to have here that on the left side, I'm going to have 2 to the power 3, which represents my 8, and which was initially raised to the power 5x Okay, and then to the right side I'm going to have, instead of 4 I'll have 2 square, which gives me still 4, and then into the initial power to which it was raised, 4x minus 7. Now that the two bases are the same on either side of the equality sign, I'm just going to equate their indices. This means 3 into 5x is equal to 2 into 4x minus 7. This is nothing else but a linear equation. I'll carry out an expansion and then I'll simplify. Here I'm going to have 15x is going to be equal to 2 times 4, which is 8x minus 14. Now if I bring the like terms together, I'm going to take this 14 to the right and then take 15 to the left. Sorry, negative 14 to the right. So when negative 14 moves to the right, I have positive 14 is going to be 8x minus 15x. I was trying to avoid a negative, but I'm there. So I have 14 is equal to, what is this? This is going to be negative 7x. At this point, I just divide both sides by negative 7, and then I'm going to have here that x will be negative 2. And that's the answer for X. Guys, if this video was useful to you, share with a friend who will also exploit it usefully. And if you haven't subscribed to my YouTube channel, do so now. You can also follow me on TikTok and on Facebook via the links I'm going to drop below the video, because tomorrow will certainly be better.